This is a presentation about the smart filtering technology that is part of Adroit photo forensics. What do we mean by smart filtering? Smart filtering is where Adroit tries to automatically identify photos that could potentially contain explicit images. It could contain image manipulation or anti-forensic attacks. It could contain faces, so on and so forth. Why do we need smart filtering? Let me take you through this. As a brief introduction, let's discuss a few problems that are faced by investigators who deal with cases that contain explicit images. Multiple devices like cameras, cell phones, SD cards, hard drives that need to be analyzed as part of a single case. Hundreds of thousands of photos as part of a single disk image. Analyzing them manually by clicking open each file is simply not efficient anymore because it's time consuming, and it's also painful for the investigator who's dealing with the child pornography case to actually open each photo completely and take a look at what it contains and go back. So can we just look at thumbnails in a gallery and get away with it? May not be feasible anymore because thumbnails are subject to anti-forensic attacks, and I'm going to be demonstrating that as part of this presentation too. Now, what our smart filtering technology aims to do is that we want to show the examiner only forensically relevant photographs and thereby dramatically reduce case processing times. I'm going to quickly take you through the settings that we have. Here you can completely customize the smart filtering, and for now I have just chosen to filter the active photos and deleted photos. You can also choose to filter the other groups of photos which are the embedded photos inactive, or the embedded photos which could be carved out, which are in deleted photos, and you can also choose to filter partial photographs. The minimum resolution is currently set at 128 by 128 for the smart filtering. Any photo that has a resolution lesser than 128 by 128 will not be filtered. We offer two main modes of explicit image detection, and I will be calling it EID from now on. So we have two modes. One is fast EID and the other is best EID. Fast EID is more suited for a triage purpose, wherein we quickly analyze a picture to see whether it contains any explicit content or not. And this is also suitable during recovery, as it would not slow down recovery drastically. Whereas best EID is more suited for post-recovery analysis, where each picture is thoroughly analyzed for what it contains. Does it contain children? Does it contain faces? Does it contain a lot of skin tone? A lot of skin in general, and a lot of other criteria are used to deem whether a picture is explicit or not. I will take you through all the other settings as part of the presentation. Let's take a look at the smart filter photographs right now. So 32 photographs out of the 286 were deemed to be filtered by one or more of our smart filters. 46 were rejected as not being filtered. These photos do not contain any relevant content that is explicit. 208 were skipped. These could contain resolutions smaller than 128 by 128, or they could have been the embedded photographs, which we chose not to filter as part of this presentation. So let's take you through these 32 photographs. The first one I'm going to explain are the explicit photos. Now this is the best analysis that we chose, and in best analysis what we do is we analyze each photo for to see whether it contains skin. Now, how do we mathematically define skin? There are a lot of metrics that go into this. Now, the skin tone, is it smooth? What is the skin texture? Are there large areas? What is the concentration? Large blobs of skin that are part of a picture? Now, all these metrics and many more lead to the identification of skin and whether a picture is to be filtered as explicit or not. Now, what we're looking at here are relatively harmless photos where with men and women in swimsuits and some babies. These pictures are not actually explicit, but they could have potentially been explicit. We can choose to sort these photos. By default, they're sorted by their file name. We can sort them by their camera here to see which are the photos that have any camera tags. Now only these two have. But the most important thing, I mean, the most interesting thing with respect to explicit analysis is we can choose to sort them by the skin tone values. Now, a picture, the amount of skin tone that is calculated with respect to the resolution of the photo is presented to you as a single percentage number, 45%, which being the skin exposed as part of this photo. Now this number is also translated as a slider here. How is the slider useful? Let me take you through that. Most common pornography analysis softwares, you make a setting to choose how much skin do you think is relevant to a given investigation, and you analyze the case. Now this takes a considerable amount of time, and you finish the analysis, and when you get the results, you might not exactly end up with the results that you're looking for. You may either have too few pictures, uh, which don't give you any information, or you may have to read through a lot of pictures that may not actually be relevant to your investigation, defeating the purpose of the filter itself. But here, you don't have to reprocess the case. You can dynamically change your filters after you have processed your evidence just one time. What I'm going to do is move the slider to the right. Here I am letting the software know that I want to see all those photos that have more skin tone. So from the default value, I move the slider right, and what I end up with are those photographs which have at least 35% skin here. Less than 35 were obviously filtered out. Now I move it back. I'm going to end up with the same number of pictures that I had, which started off with a 9% to begin with. I take it to the left. I'm going to end up with more false positives where it is not exactly skin that was determined, rather very less skin that was uh, found to be exposed. Now I'm going to take it back to where the settings were. Photos that contain faces of children and were deemed explicit get tagged under the child explicit filter. We have an experimental child face classifier that is bundled along with our smart filters. This is around 70% accurate in identifying whether a given face is a child's face, or a given child's face is classified correctly as a child's face or not. Face detection is performed by default on whenever explicit image detection is selected. All photos which have faces get tagged here. This has a more of an application from an intelligence perspective when people are looking for all those photos that have faces and people in them, vis-a-vis photos of buildings, planes, and flowers, which may not exactly be relevant if you're looking for people. Now let me take you back to the main screen to show you something here. All these photos have just a single thumbnail that is as part of this square. But we are also looking at this photo, this one, and this one here, and they have two pictures that are shown as part of their thumbnail, whereas the others just have one. Now your attention is immediately drawn to these photos, and you know that there is something different about these in comparison to the rest of them. Let's take a detailed look at what these photos contain. Now I'm going to select all of these photos from my keyboard, and I'm going to launch them in the photo viewer. So what you're looking at here is ladies in bikinis. Well, what happens is the thumbnail is actually a globe. So technically, if you're looking at this photograph in a photo gallery, what would happen is you are just going to be looking at the globe, which is the thumbnail of the photo, and which is not exactly the content of the primary photograph. Now, this is a discrepancy. This is where you cannot trust a thumbnail. This is an anti-forensic attack wherein you have replaced the primary photo behind a safe thumbnail. This is the same with the other photographs too. You're looking at a beach, but the actual photo contains children. You are looking at a lady in a swimsuit here, which is the actual photo, but the thumbnail actually shows a shipwreck. I'm going to go back. Now, these photos are depicted with two thumbnails in a given square, indicating that there was an anti-forensic attack on these photographs. I'm going to take you to the hash filters right now. And these two photographs were identical to each other. That is, their MD5 hashes matched. Now, if there are multiple copies of these photos found in a single case, now they are clustered together and shown to you here. Now, what if the photos were slightly modified from one another? What if they are not exact hash matches of each other? Can we pick them out to be true? Let me, these photos are actually clustered together. There are two photos in all of these groups, and I'm going to, if you, as I hover over it, you see that there are minor changes. Let me just launch this in the photo viewer now. As we see, this photo has a resolution of 1024 by 620, and the colors are natural. And here the photo has been cropped and resized to a much smaller resolution, and the colors are clearly saturated. If we take a look at them, they are still found to be similar, even though the photos, one photo has been completely manipulated. Let's take a look at their hash values. If we look at them, the MD5 hash values clearly don't match each other. They're completely different. Well, what's happening is we have a technology called smart hashing, which is, in this case, it deems the two photos to have similar content. So essentially, we are calculating a signature based on the content of the photo rather than calculate the hash of the actual file data. This is very useful when we are looking at photos that could have been manipulated. Clearly, these photos would not match, have a hash match on your database because one of them was modified, whereas the original photo that's on your database was clearly not. But if you were to analyze them based from a smart hashing perspective, these two photos will be tagged as being similar to each other through the smart hash value. The same thing would work if the photos were cropped and here a watermark or any text or frames were added to the single photo. I'm going to go back and show you this. This one has been it's dramatically resized. Now this photo is only 640 by 480, and this picture happens to be at a resolution of 3072 by 2304, which is almost 5 megapixels there. Now that concludes the portion of the demonstration on smart filters.